Hello and welcome back to Jacobication. This is the next video in Chapter 0 entitled Functions. A function is a group of code packaged together with a certain name. Note, there are many other different terms that are similar to a function like routine, subprogram, subroutine, method, or procedure. These have specific meanings and specific ways they work in the languages they're in. This video will focus on the umbrella concepts of functions without diving into specific terms. Add two numbers examples. As it says, this adds two numbers and returns the result. Many languages have a keyword to let you know you're starting to define a function, like def in Python and function in JavaScript. The name of the function, it was add in the example on the previous slide. You give the function a name so you can use it later. Inputs, num1 and num2 in the example. Some languages also make you state the type of the inputs as well as their names. Two different terms for these inputs that are used interchangeably but shouldn't be. Parameters are the name of the inputs when you define the function, and arguments are the name of the inputs when you call the function. Body of a function, the code you're packaging up so you can use it multiple times. General rule of thumb in coding, if you're writing the same bit of code over and over again, you should be using a function. Functions should generally only do one thing, but as you get more complex programs, what one thing is becomes blurry. So just be sure you're not trying to accomplish multiple different goals in the same function. Return statement can use return by itself to exit a function early. A function that only uses the return statement by itself and doesn't return a value is called a void function. Why is it called void? I didn't find any historical reason, but the dictionary ties void to meaning the absence of stuff, so it makes sense. Generally used to give a, meaning you can't give back more than one value from a function to the original place that it was called. In some languages, the type of the return value has to be specified within the function definition. Calling a function. Calling a function means to pause execution on the current bit of code you are executing and begin to execute this new piece of code. This jumping around seems like it will get messy and hard to follow in about 10 seconds. Programming to the rescue. Main function. Many languages define the main function as where your code will start. In some languages they have the main function, using it as optional, like Python. In some languages, the main function is called on its own. In the other languages, it's not. In this example on the side here, you define two numbers, 1 and 2, and then you call the add function with 1 and 2. So you pause execution in main, you go into add, you add 1 and 2, it gives back 3, and then answer 1 is 3. And then answer 2 is calling subtraction with 2 and 1. So you pause execution in main again, you go to the subtraction function, you subtract 2 and 1, you return 1. Answer 2 is equal to 1. And then answer 3, you call the multiplication function with 2 and 1. You pause execution in main again, you go to the multiplication function, you multiply 2 and 1, you return 2, and then you're done in main. Scope within functions. Pretty much skipping over this for now because you need to know a later concept for this to be explained well. For now, variables only exist within the function they're defined in. Recursion. In programming, recursion is when a function calls itself. The useful bits of this I'm going to skip over for the same reason as the previous slide. The below example is an example of infinite recursion. This function is similar to an infinite loop as it never ends, so you can press Ctrl-C to stop it. Printing. No, Hewlett-Packard, I'm not talking about you. When you're coding, it's often useful to print values to the screen. It varies wildly from language to language what it's called and how you can use it. So for now, I'll show you a simple Python example that just prints hello world to the screen. Pass by value, swap example. The example below demonstrates pass by value. You call the swap function from main with the two numbers, you swap them in the swap function, but then when you return from the swap function, the numbers aren't swapped, and that's what this example does. Pass by value. Copies of values are passed to the functions, not the values themselves, and this is why the example doesn't work like you expected. You didn't pass num1 and num2 into the function, actually you passed copies in num1 and num2. Pass by reference, swap example the correct way. Pass by reference is the memory address of the values are passed to the function instead of copies of the values. Generally, unless you use the language feature to opt in to pass by reference, pass by value is used. This makes the swap function properly, as now you're manipulating memory that won't disappear when you return from the function. Don't worry about the C syntax, just know you're passing memory addresses in for main and manipulating the variable's memory addresses in the swap function. Side effects. This is a term I have particular disdain for because the medical connotation immediately pops up and you think it's bad to have side effects in your code. It's not bad. Side effect is when a bit of code, function or otherwise, modifies state out of its local environment. Examples: modifying variables out of the scope of the current function, using the print function. In the next video, I'll cover stacks and recursion. Ciao.